Okay. And next one, many to one RNN. The many to one RNN receives a sequence of inputs and generates a single output. This type is useful when the overall context of the input sequence is needed to make one prediction. It is majorly find application in sentimental analysis where the model receives a sequence of words like a sentence and produces a single input like positive or negative or neutral. So this is the main working of many to one RNN and many to many RNN. They process a sequence of inputs and generates a sequence of output. In language translation task, a sequence of words in one language is given as input, and the corresponding sequence is another language is generated as output. So it's a many to many inputs and outputs. Okay, it's mainly found in language translation task. Next, we'll get into the variants of RNN. So, in this session, we are going to discuss about the four important variants of RNN, which are nothing but LSTM, long short-term memory, gated recurrent unit network, bidirectional RNNs, and echo state network. First, we'll discuss about LSTM. So, it is an improved version of RNN designated by Hochreiter and Key Miduber. A traditional RNS has a single hidden state that is passed through time, which can make it difficult for the network to learn long-term dependencies. So it is very difficult. So long-term LSTM model address this problem. Okay, by introducing a memory cell. So they'll be keeping on and tracking a memory cell, which is container in turn that can hold information for an extended period. Okay, long short-term memory, so it is capable of various memory layers of memory cell. It is also called as a container that can hold information for an extended period. These architectures are capable of learning long-term dependencies in sequential data, which makes them well suited for tasks such as language translation, speech recognition, and time series forecasting. And when we are getting into the LSTM architecture, it involves the memory cell, which is controlled by three gates. Okay, one is input gate, the forget gate, and the output gate. So these gates decide what information to add to and what information to be removed from, and what are the outputs from the memory cell. So these three gates are responsible for these kinds of operations. Okay, the input gate controls what the information is added to the memory cell, and then the forget gate it controls what information is removed from the memory cell, and then output gate it controls what information is output from the memory cell. So these three gates are handling the memory cell. Okay, which is maintained in the long short-term memory of your RNN. This allows LSTM networks to selectively retain or discard information as it flows through the network, which allows them to learn the long-term dependencies. So they're also used to learn the various dependencies, okay, long-term. The LSTM maintains a hidden state, which acts as a short-term memory, okay, of the network. The hidden state is updated based on the input, the previous hidden state, and the memory cell's current state. So, using these three terms, the hidden state is updated periodically, okay, based on the input, based on the previous hidden state, and also the memory cell's current state as well. And this is the workings of LSTM. So this architecture has a certain structure that contains four neural networks and different memory blocks called cells. The information is retained by the cells and the memory manipulations are done by the gate. So here there are three types of gates, namely forget gate, input gate, output gate. Now we'll see the functions of each and every gate, forget gate. So the information is no longer useful in the cell state, will be removed with the forget gate. The two input xt input at a particular time and ht minus 1 previous cell output are fed into the gate and multiplied with the weight matrices followed by the addition of bias. Okay, so they are multiplied with the weight matrices followed by the addition of the bias. The resultant is passed through an activation function which gives a binary output. If for a particular cell state the output is O, the piece of information is forgotten and the output is 1, the information is again retained for future use. So this will be checking the value will be always monitoring by this particular forget gate. Okay. If the particular cell state the output is 0, the piece of information is forgotten and for output 1, the information is retained for future use. This particular information is retained. The equation for forget gate is Ft is equal to sigma of Wf, okay, that Ht minus 1, comma Ht, it's a function of these two parameters, Ht minus 1 and Xt, the input parameter, and plus Bf. Okay. So Wf represents the weight matrix associated with the forget gate and Ht minus 1 and then xt denotes the concatenation of the current input and the previous hidden state. And then bf is the bias to the forget gate, and then sigma is the sigmoid activation function. Okay, and then input gate. The addition of useful information to the cell state is done by the input gate. So this is the responsibility. Addition of useful information to the cell is the responsibility of your input gate. The information is regulated using the sigmoid function and filter the values to be remembered similar to forget gate using the input h of t minus 1 and the xt. Then a vector is created, okay, using tan h. Okay, it is a mathematical term which is used for differentiating the various inputs, as we have discussed already. Tangent function that gives an output from minus, so it values varies from minus 1 to plus 1, which contains all the possible values from ht minus 1 and xt. At last, the values of vector and the regulated values are multiplied. Okay, so these two things are multiplied to obtain the useful information. The equation for the input gate is IT is equal to sigma of Wi of HT minus 1, comma XT plus BI. Okay, we multiply the previous state by FT. Okay, so disregarding the information we had previously chosen to ignore. Next, we include IT into CT. This represents the updated candidate values adjusted for the amount that we choose to update each state value. So here CT is calculated FT, okay, and then element wise multiplication. So here a dot around the circle, a dot inside a circle is denoting the element wise multiplication, and then tangent is the activation function. Okay, ft multiplied by ct minus 1 plus it, and again it is multiplied element wise with the help of ct.
You are not audible, ma'am. Ma'am, you are not audible. Ma'am.
Hello, ma'am. You are not audible, and also the screen is not shared.
Participants, kindly wait for a few minutes.
Yes, sir.
Dear participants, kindly wait for a few minutes. There is some technical issues on resource person side. Participants, kindly mute yourself.
Dear participants, am I audible? Saranya madam, am I audible?
Ma'am.
Yes.
Yes, ma'am.
Sorry for the
Yes, ma'am.
interruption.
Yes, ma'am.
Sorry for the interruption. So that's all about the input gate side. And here we have discussed that dot, that is the dot in the circle. It denotes the element-wise multiplication. And of course, tan h is the activation function whose values lies in between -1 and +1. And next is the output gate.
Hello, excuse me, ma'am. Ma'am, can you start again from the forget gate?
Yeah, sure, ma'am. Okay. So the main the information that is no longer useful in the cell state is removed with the forget gate. Okay, so this is the main responsibility of your forget gate. The information which is no longer useful will be removed by the forget gate. So basically there are two inputs. Okay, one is xt. It is the input at the particular time, and the h of t minus 1. So here t minus 1 is nothing but the previous state, where t is the current state, and h of t minus 1 is the previous cell output, which are fed to the gate, and they are multiplied with the weight matrices followed by the addition of biases. The resultant is passed through an activation function, which will be always giving a binary input. If for a particular cell state, the output is 0, the piece of information is forgotten and the output will be 1. The information is always retained for future use. The equation for the forget gate is ft of sigma of wf. Okay, so it's a function of h of t minus 1, comma xt and df. So here the wf represents the weight matrix associated with the forget gate, and then ht minus 1 xt denotes the concatenation of the current input and the previous hidden state, and the bf is of course the bias with the forget gate, and sigma is the sigmoid activation function. And while coming to input gate, the addition of useful information to the cell state is done exclusively by the input gate. Okay, first the information is regulated using the sigmoid function. Okay, and it will be filtering the values to be remembered similar to the forget gate using the input h of t minus 1 and xt, that is the current input and the previous state input as well. Then a vector is created using the tan h. It is a mathematical function whose values lies between -1 and +1. It always gives the output from -1 +1, which contains all the possible values from h of t minus 1 and xt. At last, the values of the vector and the regulated values are multiplied to obtain the useful information. Okay, the equation as follows: IT is sigma of WI of HT minus 1 comma XT plus BI, and the CT is tan H of WC of HT minus 1 comma XT plus BC. So here we are multiplying the previous state by FT by disregarding the information we had previously chosen to ignore. Next, we include IT and CT. This represents the updated candidate values to adjusted for the amount that we choose to update each state value. So CT is calculated in turn FT, and we are using the element-wise multiplication, which multiplied with CT minus 1 plus IT into CT. Okay, so that's all about your input gate. And then while getting into output gate, the main task is to extract the useful information from the current cell. Okay, cell state to be presented as the output is done by the input gate. First, a vector is generated by applying tangent function on each and every cell. Then the information is regulated using the sigmoid function. Okay, so the information sigmoid function is responsibility of regulating the information, and again it is filtered by the values to be remembered using the inputs h of t minus 1, that is previous state, and the current state xt. At last, these values of the vector and the regulated values are multiplied to be sent as the output and input to the next cell. Okay, so concurrently they'll be sent to the next cell. The equation for the output gate is OT is equal to sigma of WO. It's a function of h of t minus 1 comma xt, and it's also added with the bias function of the output gate. So this is what your output gate function. Yeah. Next, let us discuss about the various differences between this long short-term memory and the recurrence neural network. When as far as the memory is concerned, your long short-term memory has a special memory unit, as we discussed earlier. It will always allows it to learn long-term dependencies in sequential data. Of course, the sequential data is playing the major responsibility. In turn, it is used to guess the it is used to get the future data by analyzing the previous data. And while coming to RNN, it don't have any memory unit. So that's what we are migrating to long short-term memory. And then while dealing with directionality, your LSTM can be trained to process the sequential data in both forward and backward directions. That is both forward propagation and backward propagation manner. And in RNN, it can only be trained to process the sequential data, and that too in unidirectional, in a single direction. And then while coming to the training feature, your LSTM is more difficult to train than RNN due to the complexity of the gates at memory unit. Each and every memory unit will be having n number of gates. It is very difficult to train as well. While coming to RNN, it is somewhat easier than to train. Okay. And then long-term dependency learning, here it is required. In case of your LSTM, here it is limited depending upon the because of the unidirectional data transfer. And then ability to learn sequential data. So both the model training model has the ability to learn the sequential data. So that's all the comparisons between the LSTM and the RNN. And some of the applications of LSTM, it have been used for NLP tasks such as language modeling, machine translation, and text summarization. They also can be trained to generate the coherent and grammatically to correct the sentences grammatically by learning the dependency between the words in a sentence. It is responsible for grammatical corrections also. And while coming to speech recognition, they have been used for speech recognition tasks such as transcribing speech to text and recognizing spoken commands. They can be trained to recognize patterns in speech and match them to the corresponding text. Okay, it is capable of matching the speech along with this corresponding text. And then while coming to time series forecasting, they have been used for time series forecasting such as predicting stock prices, weather, and energy consumption. Okay, they can learn also the patterns in time series data and use them to make predictions and about the future events. And then coming to anomaly detection, they are applicable for detecting the fraud and network intrusion. They are capable of identifying the fraud intrusion, and they can also be trained to identify the patterns in data that deviates from the normal and flag them as potential anomalies. So this is used to identify the data which deviates from the normal flow, and also it is used to label them as a potential anomalies. It is responsible for flagging them as a potential anomalies for easy identification. And then recommender system, LSTM have been used for recommendation tasks such as recommending movies, music, and books, everything. They can learn pattern in user behavior, and also they use them to make personalized recommendations. Okay, so this is the main application of your LSTM. This is mainly applicable in Amazon, Flipkart, like online shopping, and as well as the OTTs in Netflix, okay, Amazon Prime, everything. Okay, and then video analysis. LSTM have been used for video analysis such as object detection, activity recognition, and action classification. They can be used in combination with other neural network architecture, forward networks, everything, and then convolution network to analyze the video data and extract the useful information for further analysis and prediction. And we can see the different variants on long short-term memory. Vanilla LSTM, it is the original LSTM architecture proposed by Hochreiter and Semit Baer. It includes the memory cells with input, forget, output gates to control the flow of information. The key idea is to allow the network to selectively update. Okay, so it is update selectively and forget information from the memory cell. And the second one is P4 connection. In P4 LSTM, the gates are allowed to look at the cell state in addition to the hidden state. Okay, this allows the gates to consider the cell state when making decisions, providing more context information. So the cell state will always be monitored while making decisions and also providing more context information. And some of the disadvantage problem with the LSTM is vanishing gradient. So during the back propagation through time, the gradients can become the extremely small as they are multiplied through the chain of recurrent connections. So they cause the model to have difficult learning dependencies that are separated by many time states. So this is the main disadvantage of your LSTM. Hello, am I audible?
Yes, yes, ma'am.
Okay. Okay. So here the gradient is nothing but a change in the value of quantity, right? With a change in the given variable and especially per unit distance in a specified direction. Okay. And then the exploding gradient, conversely, the gradients can explode during the back propagation, which will lead to a numerical instability and making it difficult for the model to convert. So these are all the two major problems of your LSTM in terms of these two types of gradients, vanishing gradient and exploding gradient. Then when we are coming to the computational efficiency, LSTM process sequences sequentially, meaning they cannot take advantage of parallel computation. Okay, so all are dealing with the sequential only. And training LSTMs on long sequences is slow and computationally expensive, especially on GPS. Okay, transformers, in contrast, they can process the entire sequence in parallel, making them significantly faster. And then higher memory usage. Of course, LSTM require a large number of parameters leading to higher memory consumption. This is problematic for edge devices and real-time applications with limited resources. So in devices like edge devices and real-time applications, when they're fully depending on time series and time stamps, okay, so the data varies at various across various time stamps. It is very difficult with limited resources. Okay. And next, we'll get into the next type of variant, gated recurrent unique networks, GRU. It's abbreviated as GRU. It's a type of recurrent network that was introduced to Cho et al. In the year 2014 as a simpler alternative to LSTM. Okay, GRU can process sequential data like LSTM, such as text to speech and time series data. The basic idea is to use gating mechanisms to selectively update the hidden state of the network at each timestamp. So it uses a gating mechanism. So these gating mechanisms are used to control the flow of information in and out of the network. The GRU has two gating mechanisms called reset gate and update gate. The reset gate determines how much of the previous hidden state should be forgotten. So it just defines the scale up to which extent the previous hidden state should be forgotten. Okay, while the defines how much of the so it is it is capable of quantifying how much of the new input should be used to update the hidden state. Okay, the input of the GRU is calculated based on the updated hidden state only. Okay, so this is the architecture consists of update gate and reset gate. Okay. And some of the equations used to calculate the reset gate, update gate, and hidden gate of GRU, they are as follows. So they are also using sigmoid function. RT is nothing but sigmoid of WR into H of t minus 1 of comma. It is a two variable sector, H of t my previous state and current state input and updated gate. So this is the formula. Sigmoid of W is at into H t minus 1 comma xt and candidate hidden state tan H. So here we are applying tan H. Okay, and then hidden state formula ht is equal to 1 minus zt into h of t minus 1 plus zt into ht dash, where wr, wz, wh are learnable weight matrices. Okay, so they are learnable weight matrices, and ht is the input at time step t, and h of t minus 1 is the previous hidden state, and ht is the current hidden state. Okay. GRU architecture. GRU are a variant of RNNs designated to handle sequential data effectively. They improve upon traditional RNNs by introducing gating mechanism, as we discussed earlier. So that they are having, unlike RNNs, they use two gates, and they are capable of capture long-term dependencies while maintaining the simpler architecture when compared to other recurrent models. They are computationally efficient as they require fewer parameters than models like long LSTM networks. Their ability to handle sequential data makes them well suited for tasks like speech recognition, machine translation, and time series forecasting. And this is the key components of GRU. Update gate is that it determines how much of the past information should be retained and passed forward to the next time step. And reset gate decide how much of the previous hidden state should be forgotten before computing a new state. And current memory state, it is often overlooked during a typical discussion on a gated recurrent union network. It is incorporated into the reset gate, just like the input modulation gate. Okay, it is a sub part of the input gate and is capable of introducing some non-linearity into the input, and also it is capable of making the input zero mean. Another reason to make it as a subpart of the reset gate is to reduce the entire effect that previous information has on the current information that is being passed into the future. So a single recurrent unit containing different gates is the main logic of your GRU. So working of GRU, we have discussed in the previous slides itself. And how do GRU solve the problem of vanishing gradients? The vanishing gradient problem occurs in deep neural networks, particularly in RNN, when gradients shrink exponentially. So there is a shrink happens when there is a shrink happens exponentially among gradients. They are propagating backward through the time. This leads to ineffective learning of long-term dependencies as earlier layers receive non-zero updates. Okay, so this will make the entire network unable to retain long-term information. Okay, so this is the basic major problem. And then how GRU address the issue? The GRU mitigate the vanishing gradient problem through gating mechanism that control the flow of the information and preserve the long-term dependencies. The key component, the major components involved in these types of tasks are update gate. So they determine how much past information should be retained, and they are also allowing the important information to pass through without being multiplied repeatedly by small weights. Just they ignore the small weights. This will prevent the gradient shrinkage. This helps in retaining the long-term dependencies and prevents early information from fading away. And that முடிச்சிடுறேங்க. ஆ, ஆ. திருப்பி வெளிய வந்துட்டு கனெக்ட் பண்றதா? Hello, am I audible now?
Ma'am, you are not audible.
Hello?
Yes, ma'am, now you are audible.
Thank you. So this is the working of BIRNN. So here we having inputting a sequence. Okay, the sequence of data points, each represented as a vector with the same dimensionality, which are fed into BIRNN. The sequence might have different lengths. Each and every sequence will be having different lengths, both in forward layer and as well as the backward layer. And it will be capable of dual processing, both forward and backward directions. That is the main highlight of this BIRNN. And then computing the hidden state, a nonlinear activation function on the weighted sum of the input and the previous hidden state is used to calculate the hidden state at each step. So this will create a memory mechanism that enables the network to remember data from earlier steps in the process. And so this is the formula for calculating the output from RNN unit. And HT forward is equal to this is the activation function of xt, the current input, w xh, the weight matrix of forward, plus ht minus 1, this previous state h function in forward direction into w hh, and both forward and bias is also added in the forward. So same thing is followed in the backward direction also. Okay. So the hidden state at time t is given by a combination of ht and ht backward and ht forward. The output at any given state is calculated as yt is equal to ht plus way plus by. Okay. So here the training of BIRN is similar to back propagation through a time algorithm. It works as follow. It just rolls out the network and calculate errors at each iteration. It also update the weights and the role of the network. Okay, however, because of forward and backward pass in BIRNN occurs simultaneously, updating the ways for two processes may occur at the same time. So both forward and backward process they may occur at the same time. This produces inaccurate outcomes. This is the advantage of your BIRNN. Okay, so the following approach is used to train BIRNN to accommodate forward and backward passes individually. So this process and then application of by RNN is used for similar to your LSTM. It is used for sentiment analysis, named entity recognition, part of speech tagging, machine translation, and then speech recognition. And the context from both past and future, and enhanced accuracy, efficient handling of variable and sequence, resilience to noise and irrelevant information, ability to handle the sequential dependencies, And some of the disadvantages, computational complexity, and then long training time, difficulty in parallelization. So due to the requirement of sequential processing in both the direction, so there is a challenging in parallelization action. And then overfitting. They are prone to overfitting since they include many parameters that may result in too complicated modes. So this very difficulty in overfitting. And then interoperability due to the processing of data both in forward and backward direction. They can be tricky to interpret since it can be difficult to comprehend what the model is doing and how it is producing the predictions. So in this perspective, they are somewhat lagging in the interoperability characteristic. Next, the last type of variant, echo state network of your RNN. So they are specific kind of RNN designed efficiently to handle the sequential data. In Python, these ESNs are created as a reservoir computing framework. A separate framework is there, which includes fixed, randomly initialized recurrent layer known as the reservoir. The key feature of this echo state network is their ability to make the most of the echo-like dynamics of the reservoir, allowing them to effectively capture and replicate the temporal patterns in sequential input. So that is the highlight. Okay, it will allow the effectively capture and replicate temporal patterns in the sequential input. The way ESN works is by linearly combining the input and reservoir states to generate the network's output. It also makes use of the reservoir states along with the input to generate the network's output. Okay. What sets them apart is that only the output layer is trained, while the reservoir weights remain fixed. Okay. The unique approach makes ESNs particularly useful in tasks where capturing temporal dependence is critical, such as time series prediction and signal processing. So, what is echo state network? So, ESN in Python are fascinating type of recurring network tailored for handling sequential data. Imagine it as a three-part orchestra. There is the input layer, the reservoir filled with randomly initiated interconnected neurons, and the output layer. Okay, the magic lies in the reservoir only, where the weights are likely like as a musical improvisation, fixed and randomly assigned. This creates an echo effect, capturing the dynamics of the input signal. So during the training, we tweak only the output layer, guiding it to map the reservoir states to the desired output. So this is what your input layer, and the main part is the reservoir. Okay, so the in, and from that we'll get the required output where the weights are like a musical improvisation. It will be fixed at a randomly assigned. Okay. So they are like macros for tasking involves temporal patterns such as predicting time series data. Okay, they become virtuous at capturing and reproducing the complex and the sequential dependencies. They are able to capable of reproducing the sequential complex sequential dependencies. This accessibility empowers the user to apply ESNs across the spectrum of sequential data analysis application. So ESN in Python is like a smart system that can predict what comes next in a sequence of data. Imagine if we have a list of numbers or values like the temperature each day. An ESN can learn from this data and then try to guess the temperature for the next day. So this is the echo state network. So we are having trained data sets as a reservoir, and using this we can design, and also we can specialize the output with the help of this reservoir. We can design memory. Okay. Whereas reservoir is a dynamical system, and also we can design the frequency. We can make use of the receiver as a set of the filters. So here it can have small eigenvalues as low memory, and also it is capable of having large eigenvalues for higher memories. So it is also a set of filters, and also it will be encoded as various cycles to enhance relevant pattern, data pattern, and relevant frequencies. So how it actually works? The reservoir has a special part called reservoir, which is like a pool of interconnected neurons. These neurons work together to remember patterns in the data. It's like having a memory of what happened before, similar to the human memory brain. And then training, we show the ESN some of our data and learn and let it learn. It doesn't learn everything, but gets the hang of the patterns. It's like giving a few examples to your friends so they can understand how to predict. So just it is not learning everything, okay, and it selectively it is taking from the reservoir for training the data so as to get the desired output. Predicting. Now, when we give the ESN a new piece of data, like the past temperatures, it uses what is learned to make a guess about what comes next. Likewise, the guessing is done in the reservoir. Output, the ESN gives us its prediction, and we can compare it to the real answer. If it's good, great. If not, we might need to tweak things a bit. Again, we have to reconsider, we have to go back, and then we have to reconsider the various data points in the reservoir in order to get the desired output. And some of the advantages of ESN, it is exclusively used for time series prediction and then efficient training. Okay, so where the reservoir is capable of generating the data sets randomly and fixedly, only the output weights are trained. Okay, this makes the training computationally efficient compared to the other traditional neural networks. Okay, and it's also due to its non-linear mapping characteristic. Okay, this helps to capture and model the complex relationship between the data and as well as the linear models. And then robustness to noise. So they are known for being robust to noise in the input data, as the reservoir's dynamic nature allows to filter out the irrelevant information. So only because of the reservoir's nature, it is very well suitable for robustness to noise, and also it can be considered as the universal approximator. Okay, they are capable of approximating any dynamical system. This means that they can be applied to a wide range of tasks, from simple pattern recognition to more complex tasks, okay, like chaotic time series prediction. And some of the disadvantages of ESNR, they are limited control over reservoir dynamics. So we are having positive aspects as well as the negative aspects while considering our reservoir dynamics. And then hyperparameter sensitivity. So they often rely on tuning hyperparameters such as reservoir size, spectral radius, and input scaling. So we have to find the optimal set of hyperparameters for a given task. Okay, so this will decide, okay, the sensitivity of your ESN. And the lack of theoretical understanding compared to some other neural networks, traditional neural network architecture, the theoretical understanding is somewhat not well established in case of the ESN. This makes it harder to predict their behavior in certain situations. It is not applicable for all situations. Okay, this will be difficult for certain situations. And limited expressiveness. In some cases, ESN may not be as expressive as more complex neural network architecture. They might struggle with tasks that require capturing very intricate patterns. When the patterns are very intricate, this will struggle somewhat extent. And then potential for overfitting. So depending on the complexity of the task and size of the reservoir, ESN may be prone to overfitting. So everything based on the size of the reservoir only, especially if the training data set is limited. And then some of the applications, time series prediction, speech and audio processing, signal processing. So this is widely, it can be seen in ECG and EEG, and then NLP, robotics and the control systems. So here it optimizes the movements in self-driving cars, drones, and the industrial automation. Of course, the various edge technologies, it is applicable. And in general, now let's get into the conclusion of our session. RNN and their variants play a crucial role in sequential data processing, addressing challenges like long-term dependencies and vanishing gradients. So while RNN struggle with retaining information over long sequences, advanced architectures such as LSTM, that is the various variants which we have seen so far, LSTM, GRU, BiRNN, EcoState networks, they provide efficient solutions. Okay, each variant has unique strength, as we have said already. So they excel in as a LSTM, they excel in handling long range dependencies. GREs offer computational efficiency. BiRNNs leverage both past and future context for improved accuracy. And of course, ESN, they simplify the training while capturing the temporal patterns effectively. So these models have transferred applications in natural language processing, time series forecasting, speech recognition, and robotics, as we have seen already. Overall, RNN variants have greatly enhanced the capabilities of sequence-based models, making them indispensable for modern AI applications. Okay, so that's all for about today's session. So any queries from the audience side?
Hello, am I audible, ma'am?
Yes, sir, you're audible, sir.
I have a query regarding implementing these RNNs in edge devices.
Yes, sir.
So, is it possible to implement, like somewhere you said the ESNs are having the ability to work in edge, whereas other case you mentioned RNNs are not suitable for edge. What exactly it means, ma'am?
So this ESN is it's an interactive collaborative nature, sir. Due to its interactive collaborative. Hello, are you able to hear?
Yeah, ma'am. Yes, ma'am, you are audible.
Yes. So due to its interactive collaborative nature, sir, it can be applicable for all the cases, sir. So the CSN implementation and communication and knowledge sharing in multinational organization. So when we focus on data analysis on interactions, reveal process, when we have increased number of messages to be processed, we can make use of this ESN.
And my concern is, can I implement this RNNs on edge devices?
Yes, sir.
So they are suitable. Okay. The
Yes.
next point is, assume a case where some concert is happening, and
Yes.
I have two signals from two different instruments,
Okay.
and I want to apply that particular combination to in parallel to RNNs. How it should be done, ma'am?
So repeat your question.
I got two instruments output, ma'am, two signals, both are time series, and they are
Okay.
connected. Let us say
Okay.
one person is singing, and at the backdrop, some kind of sounds or some rhythmic associated with that song is coming from some
Okay.
instrument.
Okay.
So, like to do some kind of translation or any other thing, I want to apply two input, like two signals or two features in parallel to RNN. How to do?
So by adjusting the reservoir data set, by adjusting the reservoir data
Ma'am, let me put
it
in
is
another
possible.
way. Let me put in another way.
Yeah.
Let us say we are doing some kind of translation. Then the sequence of words are normally considered only one input, where the time
Okay.
instance is changing. But now I have two streams in parallel.
Okay.
In that case, whether I have to take two RNNs or like how they will be synchronizing.
So first, the main approach of ESN is to operate a random, large, fixed recurring neural network set, which includes a non-linear response. Okay. And secondly, it is used to connect a desired output signal by a trainable linear combination of all these response. By comparing the various data sets in the reservoir, it is possible.
Ma'am,
What you're asking
ma'am,
is
what I am asking is how to mix those two. Let,
by
let me put
adjusting
another way.
sir, by adjusting the past data, by analyzing the past data,
Ma'am,
it
here
is
I got
possible.
two streams, ma'am. I got two streams for the same pass, same like two streams.
Excuse me, sir. I am
Yeah.
supposed to finish by 7:40, sir. If you
Okay,
have
ma'am.
any
Thank you.
queries,
Thank you. Thank you.
please
Thank
make
you.
a note of my mail ID. Okay.
Yeah, ma'am. Thank you.
Hello.
Yeah, thank you,
I
ma'am.
will clarify then. Okay.
Yeah, thank
Please
you. Thank you.
make a note of my mail ID. babushanti@gmail.com. babushanthi
Yeah,
at
ma'am. Thank you.
gmail.com. We will
Okay,
discuss
ma'am. Sure.
later, sir.
Yeah, sure, ma'am. Sure.
Definitely, I'll respond to your query. Right? Hello. My sincere thanks to all the audience for your patience hearing. If you have any queries, please put your queries to this mail ID babushanti@gmail.com. babushanthi@gmail.com. Okay. Thank you all for your patient hearing.
Thank you, ma'am, for the wonderful session. Dear participants,
Yes.
thank you, ma'am. Dear participants, we could break the session for a few minutes. Kindly stay tuned for the next expert session and kindly fill the feedback form for session 1 without fail. It was posted on chat box. And there is only one link for both attendance and feedback.
Excuse me, sir. Hello? Am I audible?
Yes, ma'am, you are audible. This link is for session 2.
Okay. Sir, please share the PPT, ma'am's PPT. It was having good materials.
Now we have with us Now we have with us Mr. Vaikundaraj sir. Profile of the speaker. He had done BCA in University of Madras at Chennai during the year 2008, done MCA in Anna University at Chennai during the year 2011. He started his career in SAP Technical with Prism Informatics Limited at Mumbai. He had an experience of 13 years in SAP Technical and currently working as a team lead at Danfoss Private Limited in Chennai. Welcome you for this session, sir.
Morning, sir, and thank you very much for a short and crisp introduction to all the participants. Can you hear me, please?
Yes, sir. You are audible.
Yeah, thank you very much. So, good evening, participants. So, I would like to share my screen because already it is 7:50 with a simple PPT about recurrent neural networks. So, in this session, I will be covering the basics of RNN in a very simple way. Hello. Right. Shall I proceed or yes? Yeah, thank you. So in this session, I'm going to cover the basics of recurrent neural networks and the base architecture and the types of recurrent neural networks. After that, yes, 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 I will share the screen. Please wait. So after that, I'm not going to take much time for this PPT because I have written a coding in Python so that you can know how recurrent neural networks will help in identifying the classification problem and how the accuracy and losses will be calculated. So it's a simple program. So you'll be able to understand very clearly. So right now I will be sharing my screen. Please give me some acknowledgement. 1 minute. So is my screen is audible?
Sir.
Is screen is visible?
Yes, sir. You are visible, sir.
Yeah, thank you very much. So,
Visible, sir.
sorry. Fine. So going for recurrent neural networks. So you people might be knowing the basics of so in few words, I would like to before going for recurrent neural network, is a neural network means. So a neural networks character of a human brain, how it works, which means that so our brain is capable of thinking in numbers of activities at a same time. Like the same network also has some categories of layers. For example, how the and how it has to be read and how it has to act. So this is a simple process of a neural network. So in this particular thing, going for the base introduction. So this recurrent neural network is a type of artificial neural network which is designed for data. So what is meant by sequential data? So in a sequential network, there is a particular flow of the input data has to be processed. Any type of data. So it is not like image or speech or any type of numerical data or any type of classification problems, whatever it is, classification, clustering, for any type of things. This particular neural network will be designed for sequential data. And then obviously, like our brain, we are having a memory. Likewise, the input of the neural network is just going to be the input part, and then where the processing or processed outputs or the inputs will be stored. In the sense, there is a separate layer called hidden layer, which means that the hidden layers cannot be seen by anyone. So I'll be taking the input layer and I'll be concentrating on the output layer. So when it comes to the output, there are two different categories. One is the exact output or the desired output which I require. Hello.
Please make it in presentation mode. It's better for us.
Yeah, sure. 1 minute. Is it clear now?
Yes, clear.
Yeah, fine. So, as mentioned in this slide, the key feature is the maintaining a memory of previous inputs through the hidden states. So hidden states are very, very important here. So the hidden layers are those in which it stores the previous inputs. Why it has to be stored? Which means that without storing, I will not be able to compare the output which is generated previously. So if the output generated is wrong, what will happen? I need to take that particular output back to the network, and then that will be compared with the present input. Then the output will be generated. So I need the present input and the past content which has to be compared. So for example, consider X as the present input and X1 as the uh, input which I'm taking after first iteration. So X1 and X has to be compared. In the next iteration, this X will be hidden, X1 will be present, the next X1. Now, coming for the application part. So, as I said, it can be used for many different classifications like speech, text, machine translation, or stock market predictions, which means all the applications, whatever I have mentioned here, is we should know the past input. Then only I can compare with the present value so that I can get the output, desired output. Until I am getting the desired output, this iteration will be performed. So, if the recurrent neural networks is the one where it has the capability of making itself strong by n number of iterations till the desired output is obtained. So this is the base of recurrent neural networks. Now, as I said, coming for the components of the recurrent neural networks. The first is the input layer. We know in the input layer, we'll be going to give the categories of inputs, whatever I have. The second is the hidden layer with the recurrent connections. This is the most important. Hidden layer with the recurrent connections. Recurrent connections is the one in which the comparison will happen between the existing input and the next input. Then, so for each and every input combination, there will be an output. The next will be the output layer. Based upon the number of classifications you have, the output layer has to be defined. Now, again, going back to the hidden layer. This hidden layer, can we say is it a constant? No. The hidden layers can be varied with respect to the complexity of the problem. Basically, a neural network is a complex structure, like how human brain is there. We will not be able to predict what human brain thinks at what time. So at the same category, this hidden layer will be the one where we cannot predict what is going to happen at the next time. So coming again for the human brain, if we give the correct input, our output will be correct. If I give the wrong input, the output will be wrong. So obviously what will happen? The inputs has to be correct at all the states. But when coming for a data set which consists of lakhs of samples, how will you know that the inputs are correct? There may be some inputs which are not stable, or maybe incorrect input, or even there will be missing values. So when missing values are there, what will happen? It will go for the next iteration automatically because that particular iteration will get breakup. Now, when the next input is being compared, the next state will give the output which is required at that particular iteration. So this particular iteration will give the output and it will be shown at the output layer. Now, as a human being, we will know or we will be able to know that what is the desired output required, but how the machine will know. So we have to program in such a way, these are the exact outputs which I require. So till that particular output is obtained, this particular neural network will go on processing the iterations. Now, the next main important thing is vanishing the gradient problem in the traditional recurrent neural networks. So there are many complex problems which happens in the neural networks. We will see one by one if time persists. So going for the architecture, if you see here, I have a base architecture of 3 different inputs with the 2 sets of hidden layers. So I'm going to name it as H1 and H2, and the output will be Y. So what is the meaning of this base structure? I have 3 different categories of inputs. Now, leave about the hidden layer. Don't worry about the hidden layer. Go for the output. There are 2 outputs, which is Y and Y, which I mentioned. So this can be mentioned as, or this can be referred as a dual classification problem, which means that it will be a binary mode, either ones or zeros, either yes or no, either true or false. So I can categorize like anyway according to the input, whatever you have. So the inputs may be in the form of an Excel sheet which consists of numerics, or it can be of any categories of data. And then what about the hidden layer now? So these hidden layers in H1, I have 4 different categories of layers, and in H2, I have both 4 categories of layers. So now if I check the combination of inputs, now see the hidden layer, I have 3 different X. Let's take it as X1, X2, X3. Now in the first hidden layer, all I have mentioned as H, 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 H for the simplicity. Now just rename or just imagine that as H1, H2, H3, H4, which means in the first hidden layer, for the first input or the first layer, it will be mentioned as H11. The next will be mentioned as H12. The next is H13. The next is H14. Going for second in layer, it will be called as H21, H22, H23, H24. Now, hidden layers are clear. Coming for the input layer, there are 3x. I'm going to take it as x1, x2, and x3. Now, take only the input layer and the first set of hidden layers. If I multiply these 3 inputs with these 4 hidden inputs, now what will happen? X will be multiplied with all the 4 times. So x1 into h11, x1 into h12, x1 into h13, x1 into h14. So I have 4 different combinations. Coming for the next input x2, again 4. Coming for x3, again 4. So 4 plus 4 plus 4 is 12. So now this part is over. Now what will happen? Again, these H11, H12, H13, H14 will be multiplied with the next hidden layers part, which is H21, H22, H23, H24. Now 4 into 4, 16. See the beautiful concept which is mentioned here. I have only 3 inputs. I am going to categorize the entire data set into 2 categories, but inside the 3 inputs have been transformed into 16 different combinations of inputs. This is very simple explanation for a general neural network, or it may be a recurrent neural network. You can take it in any way. This is now I am transforming this particular depth structure into a simple structure, which is RNN. If you see here, the blue color mentioned, which is the X, and H is the hidden layer, and Y is the output layer. Now, at only H, I have a loop which has the recurrent concept, which means that this will iterate n number of times till the output Y is achieved, which is required. So now this particular A, B, and C are called as the variables. A, B, C are called as the variables where it will get varied for each and every state. And for each and every iterations, it will get varied. It is not constant at all. So coming for the next, I have transformed separately. Again, A, B, C are the parameters in which we are going to get it multiplied, or the outputs which is being obtained at each and every iterations. So each and every iterations value will be stored before the next iteration happens. Then only the output which is generated will be compared with the previous value. Then it will check whether what is the desired output will be at the end instant. So coming for the types of RNN. So we have different four categories. One is the basic RNN, which is a very simple structure. And going for LSTM, you please guys, those who are the researchers and faculty members, please make a note of this particular LSTM, which is very, very important. The reason is most of the researchers now who are working on will be working on this LSTM. GRU, we started implementing, but still much of the research work is not there with GRU because it's a little bit complex. And then the last is the bidirectional RNN, in which it will work both in forward and the backward directions. So coming for LSTM alone, what is this LSTM? So this is the long short-term memory, which is used to manage the long-term dependencies. What is meant by this long-term dependency? Which means that the output which is produced at the output layer will depends upon any categories or any iterative inputs in the past value. So we will not know at what particular iteration the output is being generated with what combination of inputs. Theoretically speaking, we can say 3 inputs getting multiplied with 4 hidden layer, again with 4, 4 into 4, 16. Yes, I can have. I can say in a very simple manner, it is a 16 iteration will happen at this instant. But at what iteration we are going to get the desired output, we will not be able to know that. So the entire process has to run completely, then only you'll be getting the final output. So in this case, this particular long short-term memory will work efficiently for any type of classification oriented problems. According to my research, whatever I have did recently. This is a little bit deep structure of this RNN. So there are two different concepts. Main important thing is the fully connected RNN. Fully connected in the sense from beginning to the end. So I have given a simple mathematical term here. As I said, this ABC, the first concept, let's take y of t minus 1 and x of t minus 1, and the hidden layer value will be h of t minus 1. In the second part, which means this is the past value. So the first part which I got shown is the past value. The middle one is the present value, and the last one is a future value. So if you are clear with the digital states and electronics, you will be very clear how the sequential circuit will work with respect to the past, present, and the future values. So past will be y of t minus 1, present will be y of t, and the future will be y of t plus 1. So this particular network will mainly depends upon the past and the present inputs. Now, according to that, the corresponding inputs will be x of t minus 1, x of t, and x of t plus 1. So now coming for h of t, what is h of t? It is a function of h of t minus 1, which is the hidden layer input, comma, x of t is the, so x of t is the present, h of t minus 1 is the past. So in the first formula, if you see, h of t is mentioned as fc, which is a function of h of t minus 1 comma x of t. This x of t is the present value, h of t minus 1 is the past value. Based upon this particular value, h of t plus 1 will be generated as h of t plus 1 will be generated. So where h of t will be the new state at each and every iteration. So fc is called as the function with the parameter c. H of t minus 1 is the old state. X of t will be the input vector at that particular instant. The below line which I have mentioned here, X is the input layer, H is the hidden layer, and Y is the output layer. A, B, and C are the network parameters used to improve the output of the model, which means it is varied. It can be varied at any instant. So at the next point, at any given time t, the current input is a combination of input x of t and x of t minus 1. So the output at any given time is fetched back to the input to improve the output. So if I need the desired output to be generated, I have to go back to the fetched output which is done earlier, and then the present input which is x of t. So without this concept, this recurrent neural network will not work. Then, So the same thing I have expanded in a different way with the two different states of past and the present. But input layer will be only one. So the input layer X takes the input of the neural network and process it and passes on to the middle layer. The middle layer H consists of multiple hidden layers. So as I said, one hidden layer can consist of multiple hidden layers with the different activation functions and weights and biases. I would like to go back to the slide to say one simple thing. Here I have mentioned as X and H. In the middle, what will happen? How the generated output will be get back or will be looped into the previous value, in the sense there is a concept called weight which is mentioned as W. So x1 multiplied with the h11 will be having the weights called W1, where these weights are the most important concept in neural network in general. So when the weights are being updated, the output will be changed. When the weights are not getting updated, it will hold the previous value. Be very clear. When the weights are not getting updated, it will hold only the previous value. But when the weights are getting updated, that previous value will be changed to the next value. And then this particular previous value will be multiplied again with the next weight to give the updated solution or the updated output. So these weights can vary from W1, W2, W3 till Wn. It's according to the total number of combinations in which we have. So weights are the most important part here. Now, if we have a neural network with the various parameters of different input layers, which are not affected by the previous layer, which means that if it is not getting affected, what does it mean? The neural network does not have the memory. Be very clear. If the neural network which has the different hidden layers are not affected by the previous layer. That's what I mentioned just now, as when the current output which is generated, if it gets changed, what is the meaning behind that is the previous value is getting affected by the previous, the layer is getting affected by the previous weight, which is mentioned over there. If it is not getting affected, there are no changes in the previous layer. In this case, you have to go for the recurrent neural networks, which means that in all the sorts of layers, I'll be having the weights which will be updated at each and every iterations. Without weights, it is not at all possible to change the output or obtain the desired output. So we have seen recurrent neural networks. What is before this recurrent neural networks is the feed forward neural network. So what is this feed forward neural network? Here, in the classification I mentioned as, if you see this, the fourth part, bidirectional. It processes data in both forward and backward direction. So now recurrent neural networks falls into this category, which is called, so I have input layer, hidden layer, output layer. Now I have given input, it got n number of combinations. Let's take 1000. So out of his 1000 combinations, 568 the iteration give the best value. Okay. Now I got the output, which is yes or no at the output layer. Now this particular output cannot be taken back to the input. That is called feed forward. It is a one-way process. So input, hidden layer, output, which is the predicted one. So the decisions are based on the current input. Decisions are based on the current input. So it does not memorize this particular value, which means the earlier inputs will be erased. And there is no future scope for obtaining the next output. This is very simple to define the feed forward neural network. Forward process, that's all. When it comes to the backward process, then I can say, when it comes to the backward process, then it is easy to mention that the generated output will be taken again back into the loop so that the inputs can be compared. So for comparing, I should have another value for comparison, which means two minimum values are required for comparison. So if I say x1 as the next input, the earlier one is the x. So x1 and x has to be compared, the output has to be produced. Now go for the next iteration. It is not the desired output. So system found that it is not the desired output. So again, this x will be vanished, x1 will be present, x2 and x1 will be compared. The next x3 and x2, next x4, x2, x5, x4. So it will go in sequential mode. This is called sequential operation. It cannot jump over to any number as it likes. So this is called sequential operation. So this types of recurrent neural networks or any type of neural networks is best suitable only for sequential operation. Coming for the applications of a recurrent neural network. So how this can be defined, or what are the basic applications that we can use? So the first, I can say the image captioning. For example, I am going to train a neural network with a lot of images, So in that one image I have taken, which is the a dog which is jumping from one place to catch the ball. But as for the human, I am saying still now, I had given the word like a dog is jumping from one place to another place. In the midway, it is catching the ball. So now, but how the machines will take, or the AI content will take here in the sense, they are used to capture an image. So that has the capability of naming a image about what it does. So here, if you see a dog catching a ball in mid-air. So this is the caption which it has been given to that particular image, which is done by the recurrent neural network. The next application is, I will come for NLP later, coming for the time series prediction. So time series in the sense, so predicting the prices of stocks in a particular month. For example, I have a particular 10 company stock prices, what happens in the last 3 months. So I have a complete data set. So now, based on those 3 months data, I'll be able to predict the price of the upcoming month. The prediction can go false, the prediction can go true, or the prediction can be neutral. Anything can happen. We cannot say this is what going to happen, because regarding to stock market analysis, we can think that tomorrow the stock market price, the stock of this particular company can rise. But when the opening of the account, what will happen? There might be a drastic fall, so that again the stock market price will go low. So this type of time series predictions can happen. Any type of data set of the problem which depends on timing is referred to as a time series prediction. So a series of problems will be taken for this particular type of prediction. The third example is the machine translation. Now, I can say Google is the best example for this recurrent neural network. Why? Because if I go to Google Translator, I'll be able to type in one particular language. I will be able to change that particular output category in various languages. But the input is same. The same image I have shown here, a person who is speaking over the phone, that is being converted into multiple languages. We are not changing the input at each and every time. Input is constant. But only the system which have been programmed is in such a way that it will be able to translate into n number of languages as per how I am going to define to the machine. It's all about how you are defining to the machine. If you define wrong, you will be wrong, or which means that the recurrent neural network will be wrong. If you define right, it will give the right. So how you are planning to make the system to be very, very easier, it will make your work easier. If you are tough, it will be tough. Going for NLP. Now, text mining and sentiment analysis can be carried out using a recurrent neural network for natural language processing. So now, I would like to say one example. Even the coding which I have taken is depends upon this NLP only. So now see here, the statement which I have given here, when it rains, it look for rainbows. When it is dark, it look for stars. This is a positive statement because this is the sentiment which has to occur in real. This has to happen in real. For example, if the statement is like in the opposite way, when it rains, it look for stars. When it is dark, it look for rainbows. That is negative sentiment. That cannot happen at any point of time. So, for example, by giving the data in terms of a bulk data, which has maybe 50,000 or 1 lakh samples with two different classifications of positive and negative sentiment, what will happen? Based upon the mood or based upon the mentality of that particular inputs, whatever I have, this will predict the output. So for example, here I'm going to take only two different classifications, which means a binary classification problem in which I have some sentimental analysis based upon the one particular data set which I had taken from Kaggle. I think you all people know about Kaggle database, where it is a housing of lakhs of data set which is being used by researchers worldwide. Any type of data, image data or numerical data, or it can be like data, anything. So if you go and take any type of data set with respect to text mining and sentiment analysis, you'll be getting a lot of data sets. So going for the types of RNN. So I'm not going to be depth in this particular part because it will take a very long time. I'm going to give a sample or a simple definition. So there are 4 types of recurrent neural networks: one-to-one neural network, and one-to-many, many-to-one, many-to-many. So by the word itself, you can be able to very simply identify. For example, if I'm going to give single input, it is going to give single output. And one input can be converted into multiple outputs. Single input can be converted into multiple outputs. And multiple inputs can be able to be give the multiple outputs. So these are the 4 simple categories of recurrent neural networks. So I'm not going to be very depth in this category. Coming for the a major part. So whatever the content which I had shared now is all because you have might have gone through all these particular definitions in earlier sessions, whatever might be. Coming for the frameworks and tools where we can use this recurrent neural networks. There are a lot of tools available which is open source, and it can be it may be even paid also. So the only thing what you have to know when going to use the recurrent neural networks is what type of inputs you are going to give. The next is what type of database or the dataset you are going to take, and then how it is going to pre-process, and how we are going to implement the dataset processing. That is the main important thing in the recurrent neural network implementation. But to be very frank, as a researcher, I will say very clearly, using this particular recurrent neural network is not very, very easy. The reason is, if you are not knowing the input parameters which has to be given, you will not be able to learn in an effective manner. So these are the 4 different tools which is in present used by many of the researchers worldwide. The first is the TensorFlow, you might be knowing, which is behind the Python framework, and Keras, PyTorch, and scikit-learn is a library which has the n number of models in the Google Colab. Even if you go and use, you can go for Google Colab also. So these are the frameworks. So coming for the real-time applications, as I said, the first is the NLP, the second is the speech recognition. So which I will be able to, the system will be able to recognize what type of speech you are giving to the network. Stock market prediction, healthcare, which is the most important thing currently, which even I am also working on this healthcare, predominantly on diabetics, mellitus, and heart disease predictions. These are the major research work area I'm working on, and autonomous vehicles. So these autonomous vehicles have not been into very depth research, but still for decision making process, they can use this, or they are using this autonomous vehicle applications recently. So challenges and futures we can say, because whatever might be the system, any new system comes in, there are challenges as well as accordingly there will be a future enhancements can also be done. So exploring the gradient problems which is happening in the current neural network structures, and then expensive training. So when speaking mathematically, it is very, very difficult to go for each and every iterative process. And it requires large data sets. Be very clear, it requires large data set with a minimal amount of data set. There is no need of going for recurrent neural networks because it is basically a complex structure. If I have the data set numbers in higher value, then you can go for the neural network structure. Basically speaking, human beings as us, we are also very complex in nature. So we have the capability to solve uh, higher capacity of problems where small problems can be solved by any category of people. So how this enhancement can be taken for further? For example, transformer modeling, because you know very well this transformer modeling is the one in which the current trends everywhere it is getting rolling out. So the transformer models which can replace a recurrent neural network, because which means that it is the AI model. So hybrid models. So what is hybrid model? So combining two different base models will give the hybrid model. So this is one of another area where I am working consistently on these hybrid models, because I used to combine two different methods, generally with optimization techniques and neural networks, because input is the major problem in the neural network. So what I will do is I will take a specific or the optimal optimization technique. I will optimize the complete inputs through that optimization. I will give the optimized input output of that particular program as a input to the neural network, which means that it will save my computational time with RNN. This is one important thing which we can, which you have to know about it. And quantum computing applications in sequence modeling, because I am not very good in quantum computing, but still the applications of quantum computing is very, 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 very exorbitant, which we cannot even think about it. So coming for the conclusion part, so these are powerful for sequential data, but have limitations, as I said, challenges. And then LSTM and GRUs improve efficiency. So in a neural network, if I use LSTM network or a GRU, a gated recurrent neural network, definitely it will improve the accuracy and minimize the losses. So future models maybe have the concept of overcoming the recurrent neural network drawbacks with the advanced architecture like transformers, like ChatGPT is also a transformer model. And recently, China has given breakthrough in the entire beat for US. We can say it's a Kimi. I don't know how many of you came to know about this. This is another NLP which they have come out as a successor for ChatGPT and OpenAI models. So the hands-on implementation helps in understanding the real-world application. So I'm going to focus on this fourth point now. Hands-on implementation helps in understanding the real-world applications. So I'm going to stop the session here, and I'm going for a practical implementation of this network. It will not take much time. So I'll be trying to complete within 10 minutes of time, because it's a very short coding in which everyone can easily understand. So shall I go forward for sharing the screen of the program which I have done in Colab? Is people available there?
Yes, sir. Yes, sir.
Yes, sir.
You go
Yeah,
ahead.
thank you. Thank you. Because it is completely state like idle. I don't know. Fine. So I would like to take the model. It's a little bit, the program seems to be a little bit complex, but still you will be able to easily understand how it will work, because this coding has been done already. So right now we don't have time to write the complete coding. So give me some time, because I need to upload the data set here. Let me check whether that will work or not. Unable to connect to runtime. I think I'm facing problem in the yeah. So there is a particular uh, give me some time here. The data set is loading right now. Uh, because in Google Colab, it should be a real-time operative. If I am not getting connected to the internet, I won't be able to show, but still I'll be able to show the coding and the result whatever I have generated. Uh, give me just a couple of minutes. Give me some time. I will save this notebook and then I'll open it again. So okay, I got it. I will share the screen now. So, are you able to see the screen, the coding screen?
Yes, sir, we are able to see.
Okay. So now see here. Uh, Now, if you see, this is the Kaggle portal in which I have taken the dataset. So, this is the mostly I think you people will be from computer science or any other department, but it will be useful for anyone. If you see here, I'm having the tab called dataset. If I go ahead, I can see any type of trending data sets, and if you give the category, I'll be able to, for example, if I see, I'm going to type the data set which I have, diabetes, it will display all the coding parts and anything which is being currently in peak level. So my most of the search will be related to only diabetes and heart disease prediction. This is one type of search which we can able to know that. And we have a discussion session coding, maybe there, which means the general codings and what are the available models. You can go and find various models in this particular tab, any type trending model. See here, for example, DeepSeek, Mistral Small, and DeepSeek. And this DeepSeek is going viral nowadays. And the basic thing like logistic regression for binary classifications, n number of models are available for you to practice. How can I classify the images? And then even I have contributed a few codings in the Kaggle, but I don't publish that, since it is like some of the research work which we have. And going for the current session which I have taken right now. See, for example, this is the Google Colab. I think everyone might know about this. If I see here, I have taken this IMDb dataset. But basically speaking, this IMDb dataset is the one dataset I can show here itself. What is this IMDb? So see here, it is a sentiment analysis dataset. It is a sentiment analysis. So the coding which I have, uh, please respond me if you are not able to see the screen. I'm trying to take the code dataset which I have. Okay. So, due to very short span of time and network connectivity, what I did is this IMDb dataset I have taken for an analysis, which have 50,000 samples. What it means? 50,000 samples. So I will open and show the dataset here, and then I will take. I have taken another one dataset, which is the uh, simple part for this session, because the Google Colab needs a real-time uploading. So let me see how I can. Okay, so now I'm going to stop sharing this. I'm going to share the dataset screen now. So then you'll be clear with that. So is the dataset is clear now? Can you able to see?
Yes, sir.
Fine. So these are the review comments which has been posted by different viewers. And then they have given a sentiment which is the positive and negative. So if I filter this Excel, one minute, if I filter this Excel, I'll be able to see, I think you are also able to see this live. See, I have only two different options, negative and positive. This is called binary classification, either this or that. Even I can convert this data set into positive, negative, and neutral as well. I can change the values of few things for analysis purpose, but you cannot change the original data set. These are the reviews which the viewers have given it. Now, if I see how many samples are here, it is around 50,000 samples are here. 50,000 samples are here. But as it takes long time for uploading, what I did is Before that, I would say the total number of negative samples are 25,000. At the same, the total number of positive samples are also 25,000. So this type of data set which has equal amount of classification is called balanced data set. This is called balanced data set. So when I'm going to use any machine learning algorithm for the purpose of classification, if I use the balanced data set, it is not a challenging one. It is not a challenging one because out of 50,000, 25,000 is positive, 25,000 is negative, equally balanced. So now I'm going to apply some machine learning algorithms over this for prediction to learn the characteristics of the algorithm. Simple to know the characteristics of the algorithm. So now what I did is I'm going to close this particular screen now. I'm going to show another one data set which I have taken, which is a modified one. For this session, I have taken that. So I have removed samples from the original data set. So if I want to share this, see here, I have taken a modified data set of this particular, the original one. If I see the number of samples are only 99, not even 100. This can be easily uploaded. So now if I see the sentiment, see here, if I see the sentiment, if I go for negative, negative is 58. Negative is 58. Out of 99, 58 are negative. And then positive is 41. So slight variance is there, which becomes an unbalanced data set. 58, 41 out of 99 samples. So now this becomes the unbalanced data set or imbalanced data. Working on these types of data set is the challenging task when coming for machine learning or deep learning or data science, whatever it is. Now again, I'm going to close this. This is the data set I have taken for uploading in the Python Colab. I will show that as well. So now if I want to share the screen of Colab, it's the Colab, I think. So are you able to see the screen now?
Yes, sir.
So let me maximize little bit so that you'll be able to see clearly. See on the left side, I tried uploading the original dataset, but I'm not able to because it was taking a lot of time. So I had taken the modified one, which is IMDb. So now I have taken LSTM, which I said LSTM is used for maximizing the accuracy. Because here the accuracy will be low. I am telling very frankly because I have reduced the number of samples. So for demo purpose, I'm using this particular sample. So now see here. Now if I start the coding, so in Python generally, as I said, TensorFlow is one of the important thing. I am going to upload few of the libraries. So these libraries are not pre-built, but I have to import it from Colab dictionary. So I have taken because the basic process in machine learning is if I have a data set, I'm going to acquire the data set into the database. From the database, I'm going to access the data. If I find any improper data, I'm going to pre-process. Here, see here, I have two different things. One is the text and another is the sequence. So I need to pre-process both text and sequence, and then it is going to be the sequential model in recurrent neural network. As I said, sequential problem. Then I'm going to take, because I'm going to convert this particular data into embedding part, and then I'm going to take LSTM, and then the dense is the layer, which is used for classification. Then I'm going to import the data set which I take, and then This NumPy and Panda, these both are pandas are both, which is very mandatory for Python coding process. And then this plotting is used for plotting the graph. So now coming for the parameter. So these parameters are constant for it. Sorry, this is not constant. This can be variable based upon the type of or complexity problem which we are taking. So now I am going to take the vocabulary size, which means the text, because I'm going to take the text. So this vocabulary size is very important. Maximum length, I'm going to take the sequence as 100. And then embedding dimensions will be 128, which is the vector size, because this is a little bit deeper, which you may not know. But still, if you mail me personally, I'll be able to give entire explanation for this. And then LSTM, which I said, which is the major important thing in recurrent neural networks, and batch size and epochs. So these epochs I can improve, which means epochs is the iterations, which I can improve it to 100 or 1000. It is up to you, because if you have enough number of time, you can increase iterations. Now I'm going to load the data set here, which is load your data set. This is the basic command. See here, this name which represents the dataset. It has to be same with respect to the CSV file. I can upload any type of categories of dataset here, but it depends upon the category type of data. If it is an image, the extension should be different. If it is an Excel file, it should be CSV. According to that, I'm going to read the entire column which is available in the dataset now, because the program should know what are the types of headings are the labels available. So one label is the review and another label is the sentiment. So if it is a review, now I'm going to check the sentiment, because sentiment has only two types. One is positive and negative. So now it is going to take positive as 1, negative as 0. So which means this is converting string labels into numerical. So it is very easy, because this is one type of data pre-processing, which means conversion of data set from one mode to another mode, or one form to another form. So now I'm going to change the label from label to sentiment. So because this is the outcome which is going to be predicted by the neural network. Now coming for the pre-processing step, I'm going to tokenize the words, which means tokenizer is nothing but it will fit on the particular text where it has to be, because this tokenizer will not be able to overlap with the dataset which has been present in the datasets. Now, when coming for machine learning, there is one important concept which is called training and testing. So basically speaking, this particular training and testing, training will be used for training the model, testing will be used for testing with a few samples, which means that I have 99. This training I have taken 2080. More in general, this training should be higher and testing should be lower. It is like the total number of students to whom you are taking classes. You are taking 5 units in a semester, but at the end of the exam, you are taking only one question from each unit for testing the student's knowledge. That's all. This is called simple way of understanding the training and testing model. So by using a code from sklearn.model selection input training and test split, I'm going to split the data into training and testing model. See here, by mentioning the test size of 0.2, which is 0.2 means 20%. So test size is 20%, training size is 80%, which means 0.8. It will automatically take or convert the data set of remaining 80% into training. Now coming for the main part, how I'm going to take the training and testing part, and how I'm going to build the LSTM model. This LSTM model, if I take, it will be another 1 or 2 hours more session. So I'm going to give a very simple thing, which is the basic command for this LSTM model. So I'm going to work on sequential problem. So as I said earlier, I'm going to embed the vocal size and then embedding dimensions and input length, because if this length exceeds the number of cells in the Excel, the output will be error. And now I'm going for LSTM model, which I said number of LSTM units and the return sequences, it always has to be false. You should not change it to true. And dense. This dense is called the one in which the activation layer. So this activation layer is called, it may be referred as a spark, which is happening in our brain. There are many categories of dense layers. The most famous are sigmoid and ReLU function in neural networks. So you should be very clear with the sigmoid and ReLU when going for deep learning process. So now I'm going to compile the model together. So now I'm going to take the optimizer as Adam, and I'm going to measure the output value as the accuracy, which is the calculate predictive metric. Then binary cross entropy. Binary cross entropy in the sense I'm going to take the binary model of the problem where it has only two classifications, either positive or negative. That's all. Positive will be 1, negative will be 0. Now I'm going to fit the model in the training history, which means because why this history is required. As I said, in recurrent neural network model, I need the past history which has to be stored. Without that, I will not be able to run the recurrent neural network. So this is the main thing which it has to store the previously executed values so that it can compare with the current value. Now, after storing this, I'm going to evaluate the model. What is the testing loss? Which means I'm going to take two different categories. One is testing loss. The accuracy which is obtained through the testing accuracy is the final accuracy. Be very clear. Not the training accuracy. Training accuracy will always be higher only because it has more number of samples. But when coming for testing, we don't know what type of inputs we have taken. So it can be random structure. Out of 99 inputs, there may be 48 negative category, but still out of that 48, how many samples have been taken in 20% of testing or how many can be in 80% of training? We don't know. Only system knows. That is called hidden layer. That is called hidden part. Now, coming for why I'm going to save this model. This is not required actually, but I have taken this particular coding. I'm going to plot the training accuracy as well as testing model and losses as well to show the comparison how it goes. So plotting the accuracy, this is plotting the graphs, how I need, how many number of epochs. And for that epoch, what is accuracy? So the first one will be the training and validation accuracy. And the second plot will be the training and validation losses. This is the end of the coding. When I'm going to execute this particular coding, I have given only 5 epochs. If you see 1 minute, if you see here, iteration 1 bar 5, 2 bar 5, 3 bar 5, 4 bar 5, 5 bar 5. So what is the time taken for execution of first iteration? 739 milliseconds per step, which means to take this is the first iteration, second iteration, it is taking 174. If you see the first iteration, it has taken much time for processing, but starting from the second, it has taken only 10% of that, which not even 10. It's 174 milliseconds per step because it has generated one output already. Now it is going to compare the next value. So the number of iteration seconds or the computational time will go less when the iterations are going forward. So you can see the first accuracy is 52, the second is 60, the third is 62.7, and the fourth is 62.8, and the fifth is 60, and the loss accordingly the losses. So now at the right side, if you see the validation accuracy and validation losses will be here. So now I have plotted the entire training and validation accuracy at one part and training and validation loss at one part. So this particular x-axis represents the which I have taken from 0 to 5, and then the accuracy stating ranging from what is the value which is taken. So see here in this training, it has given only 50, this is 52, 53, 54, 55. It stands at an average of 53 at the initial state. When the iteration goes forward at particular iteration of 1, it becomes constant, which means that there is no change in the input layer. There is no change in the input layer. So now this particular accuracy 62.5, I can take it as the maximum of training and testing accuracy. So coming for training and validation losses. So the same losses, whatever I mentioned here, it has been mentioned over here with the training loss and the validation. Validation is called testing. This is training. So training loss gets end up at the maximum at the 5th iteration. The training loss is approximately 69 point something. But if you see the training testing loss, it has reached more than 72%. So by basically speaking, rather than the training loss, the testing loss becomes higher because actually it has been the reverse way. The reason is I have reduced the more number of samples in the training data set. This is only for the demo purpose which I have taken here. So in this way, if I upload the entire IMDb dataset, if I check the training and validation losses and accuracy, it will be more as per your expectation. Now, how this particular accuracy can be increased in the sense, one particular thing we have to do, we have to go for these parameters. So now I can improve the accuracy, iterations. As I said, this iteration part is more important in the neural network. As and when you are increasing the iterations, obviously there will be the increase in the accuracy because we have a LSTM model. But the thing is, as I said, only for high samples of data sets, huge number of samples of data, this will work properly. Then only we can go for neural networks, or else I can go for any other simple methods which we have, which we're using in the basic uh, methods like machine learning or regression methods or any other different things. So this is all about the general thing about how we can work with respect to Python or TensorFlow. Uh, yeah, simple coding, that's all. So I would like to end up the session here. So if you have any doubts, you can ask me over here with respect to this particular topic or any other like machine learning, whatever it is. I'm ready to answer.
Good evening, sir. I am Sajita. Sir, I am
Yeah, good evening.
basically from Triple department, sir. And like what you have
Right.
shown using Google Colab now, is it possible for us to do the very same thing and get the same result from MATLAB? Because we generally use MATLAB.
Yes,
Uh,
even I'm also basically because I know how the Triple people will be working on this. It can be done. The reason is, but right now in MATLAB, what they did is you have to develop coding in the same way because we have a lot of tools which can convert the same Python coding can be converted into MATLAB coding based upon the data set what you're going to use. So what you have to do in the main MATLAB console, you have to convert this particular coding into MATLAB coding. The same neural network structure can be drawn, but you should be very strong in the mathematical model. That is the only thing we have to be very clear with MATLAB. Because I thought of taking this session in MATLAB, but due to time constraint, I had gone with Google Colab.
okay, sir.
But yeah,
Sir,
one
if it
minute.
is
Another thing
possible,
is
like,
there.
yes, sir.
Another thing is there in MATLAB. Now we have a lot of inbuilt blocks available where you can go ahead and customize your blocks according to the requirement. But that is not much effective rather than how we are writing the coding for any type of problems.
All right.
This can be done.
Okay, sir. Okay.
Yeah.
Fine. The simulation,
sir.
I mean, yes, sir, please.
Yeah, tell me.
Hello, sir.
Someone. Yeah, good evening, sir.
Right. Shall I continue or ma'am is going to be asking?
No,
So you can please continue, sir.
Yes, sir.
Sir, you are explaining about optimization and then feeding to RNN. Right? Can you elaborate
Yes.
on this with example?
Sorry.
Can you elaborate it with an example? Like in the middle
See,
somewhere you mentioned about
elaborate in the sense it is around 8:54. Let me see. I can put it in a very short note. For example, what is the purpose of optimization in the sense? For example, if I'm going to take a particular problem in optimization technique, where I'm going to take a set of inputs. For example, this neural network, rather than feeding the input directly. So what will happen? I have shown some basic structures of networks here, like basic feed forward, recurrent, and whatever I have taken here. If I'm going to feed the network directly with respect to number of complexities, whatever you have, this will take a lot of time to process the inputs with any type of networks. I think I'm clear with this. It depends upon the huge number of samples of data because I have worked completely with respect to nearly 3 lakh samples of data. Even I have worked with respect to recurrent neural networks. What will happen is it will take hell number of time to process the input from input layer to the hidden layer. So what I did is I have taken many optimization algorithms which I'm familiar with. So recently I was working on one particular optimization called a chimp optimization, which represents the characters of monkeys. So we have taken that particular optimization problem. We have fed that data into that optimizer. Then what happens? that particular optimizer will come out with the different combinations of inputs in which it has to take part in the neural network. So I am optimizing the input, which means that in simple way, I can say this optimizer will help in removing the unstable data, which will make the system accuracy will go low. So once this particular optimizer is done, I have taken this particular input into the neural network input structure, the output into the neural network input structure. So the timing which it takes from transferring of the input to the neural network hidden layers got sustained for me so that my neural network started working very fast. This is the way in which the optimized input can be given to the neural network inputs so that your accuracy, system accuracy will get higher. By default, I have attained nearly 96% of accuracy. When I have taken the same data set, I have given directly to the neural network inputs, but it has given only 65% of accuracy. So it depends upon the characteristics of that particular algorithm which we take, which means the optimization which we take.
I have two more questions to put in short. Like my data is two streams rather than one stream, one sequential.
Okay.
I have two streams. One is magnitude and second one is phase kind of thing, corresponding to the same phenomena. Then like in all these cases, we were speaking about only one input, right? Then how it should be handled?
Sir, not only because I have taken single dimension. That's it. See, the reason is you can go ahead with the two different kinds of inputs as well. But the thing is, when you are going for different categories of inputs, then you have to go for two different types of networks. Then you have to combine with the one function is there in the deep learning technique, but I forget because I published a recent article in that particular fusion score. Yes. Now, with respect to first input network, I need to generate one output. With respect to the second input, I need to generate an output. Then with the help of fusion score, I need to combine both two. But it is very, very difficult. We cannot do it very easily. Because as you said, it is magnitude and phase, both are different forms.
But they are connected. Actually, for a single variable, like complex number.
Yes, both are connected. I know both are connected, but how the machine will know?
Yes, sir. Somewhere when I gone through this, somewhere it was mentioned something like first I have to give magnitude information in series and then phase information in series.
That is what I'm telling. It has to be processed separately. It cannot be in a single phase.
And lastly, like how far it is efficient to implement in edge device like Raspberry Pi or ESP32 kind of thing?
Sir, actually, to be very frankly speaking, I don't know about this Raspberry Pi and other things because the reason is, but I can give the answer for this because I had gone through this problem with my colleagues as well. When you have this advanced Python thing, if you convert this particular coding into another form of like Raspberry Pi or anything else, it will not work fine. Because each and every device has its own characteristics. It will work perfectly only with that coding. As earlier Sajita ma'am was asking whether the same coding can be implemented in MATLAB. Yes, we can. Any type of conversion is possible. But the only thing is you should be very clear with the mathematical model. If your mathematical modeling is not clear, it is not at all possible to work or convert any type of coding into another form. So my answer would be like it is not that much effective with respect to a Raspberry Pi when you are going to use this. Because I am not very much depth in Raspberry Pi, so I'm telling about this. But this is the answer.
Okay, sir. Thank you.
Thank you. Thank you very much, sir. Any questions else? Okay, fine. I think I can end up the session. So thank you very much for patiently listening this particular session. So I think I have given my best. If you have any doubts, I'll be sharing this particular PPT because it is not that much depth due to the time framing constraint, but still I will share this to the organizers so that you can get it from them. If you have any doubts, you can post it.
Sir, can you share some resources links also if possible?
Definitely, sir. I will give that. We have a lot of resources. for this RNN. So where
Also
you
your
have to
mail
be very
ID, sir.
sure, ma'am. Sajita, ma'am, what you are asking?
Your mail ID, sir, is it possible to share? So
Sure,
that can
sure,
we
definitely,
contact?
ma'am.
Yeah, yeah.
Definitely. It is available with the organizer so that you can get it from them. No problem.
Yes, sir. Thank you so much.
Yeah, fine.
Yes.
Anybody else? Okay, fine. Thank you very much to all the participants for patiently listening the session. Thank you very much. Have a great day and good night. Thank you.
Thank you for the marvelous session, sir.
Thank you very much, sir.
Yeah, participants kindly fill the attendance and feedback form for session 2 without fail. It was posted on chat box. And thank you. Stay tuned. We will meet tomorrow.